Hello guys, today I'll be going over the 2025 AMC10B Problem 16. So, circle has been divided into 6 sectors of different sizes. Then 2 of the sectors are painted red, 2 painted green, and 2 painted blue, so that no 2 neighboring sectors are painted the same color. How many different colorings are possible? Alright, so let's draw a graph with 6. So now, without loss of generality, let's set this be R. So now let's do casework on where R can be. So case 1, R is in this top left one right here. So then this means that we must have greens here and blues here. And we will handle colors later. So there's only one way that we can do this, because any other way would let the greens touch. Now let's take a look at case 2. Let's let R be here and let's R be here now. So now we can either have blue, blue, green, green, or you can have blue, blue, green, green. So there's 2 ways for that. And by symmetry, we know that the next case is also 1, because this is just the same thing. So in total, we have 4 cases. Now we can order the colors however way we want. So this is 4 times 3 factorial, which is 24. So thank you guys for watching. AMC10B Problem 17. So consider a decreasing sequence of n positive integers. x1 is greater than x2 is all the way to xn. It satisfies the following conditions. The average of the first 3 terms in the sequence is 2025. For all 4's less than k is less than n, the average of the first k terms is 1 less than the average of the first k minus 1 terms. So what is the greatest possible value then? So to construct a sequence, we always start with a minus d, a minus 2d. The average of the first 3 terms is 2025, so we get that 3a minus 3d is equal to 2025 times over 3 is equal to 2025. This means that a minus d is equal to 2025. Now step 2. Now let's look at when there's 4 terms. So a minus d, a minus 2d, a minus 3d. Summing these up, we get 4a minus 6d all over 4 is equal to 2024, as that's 1 less than 2025. So let's cross out a 2, and then since there's no more 2's left to cross out, we multiply. So we get 2a minus 3d is equal to 4048. And on top of this, we have 2a minus 2d is equal to 2 times 2025, which is 4050 from this equation. So now, using these 2 equations, we can figure out that d is equal to 2. And consequently, since a minus d is equal to 2025, a is equal to 2027. So now we know our sequence is 2027, 2025, all the way down to 1. And we want to see what's the greatest possible value of n. Well, the nth term is going to be in the form 2027 minus n minus 1 times 2n minus 1, or 2029 minus 2n. So now, the maximum possible value of n is 1014, which is the answer, because it has to be positive integers, and when n is equal to 1014, it's equal to 1, and anything past that will be a negative number, which won't be in the sequence. So, if AMC10B Problem 18. So, what is the 1 digit of the sum of the floor of square root 1 plus the floor of square root 2 plus the floor of square root 3 all the way to the floor of 2025? So, basically, first of all, we got to realize what this means. The floor of 1 is equal to 1. The floor of 2 is equal to 1, as because the square root of 2 is 1.44. Square root of 3 is also equal to 1. But the square root of 4 is now equal to 2. So what this means is that our sum is going to be 2 squared minus 1 squared times 1, and plus all the way down. And so what this means is that every number from n squared all the way to n plus 1 squared minus 1, the floor of the square roots of all of these is going to equal n. And so the number of integers in this area is just n plus 1 squared minus n squared. So this is why we come up with this formula 2 squared minus 1 squared plus 1 plus 3 squared minus 2 squared times 2 plus all the way to 45 squared minus 44 squared times 44. And there's 1 extra 2025, which is 45 squared. So now how do we sum this? So let's break this down into many sequences. Our first sequence is 45 squared minus 44 squared plus all the way down plus 2 squared minus 1 squared. Since there's only one copy of these, our next sequence is 45 squared minus 44 squared plus all the way plus 3 squared minus 2 squared. And then all the way down until 45 squared minus 44 squared. Now we notice that all of the squares cancel out except 1, and this continues for all of them down. Since there's 44 squares here, this is 44 times 45 squared minus 1 squared plus 2 squared plus all the way to 44 squared. So now we know the sum of this is 49 times, no, sorry, not 49. 44 times 45 times 89 all over 4, all over 6, and this. So now we only want the ones digit, so we can take a mod 10 for only the ones digit. So we know that taking mod 10, we have 4 times 5 squared minus, let's do 22, and this is 15. 2 times 5 times 9. And so this is just equal to 100 minus 90, which is equal to 0 mod 10. Now, not to mention, we still have a 45 here we need to add. And so 45 mod 10 is going to equal 5. Thank you guys for watching. AMC10B Problem 19. So a container has a 1x1 square bottom, a 3x3 open square top, and 4 congruent trapezoidal sides as shown. Starting when the container is empty, a hose that runs water at a constant rate takes 35 minutes to fill up the container up to the midline of the trapezoids. How many more minutes will it take to fill the remainder of the container? Basically, what we can do is we can take this trapezoid and extend it to form a pyramid. Now, by some area ratios, we know that since the base of this is 1, this is going to be h. This is this is a bad diagram. This is going to be 2h, and this is going to equal 3h. Now, the area of this portion is going to equal h over 3. The area of this portion is going to equal 8h over 3 because the base of this is 4, and the height is 2h. And similarly, we have 27h over 3. So now we know that this portion is going to equal 8h over 3 minus h over 3, or 7h over 3. And this portion is going to equal 27h over 3 minus 8h over 3, which is equal to 19h over 3. So we know that the area of this portion to this portion, the ratios of that to that, is going to equal 7 to 19. So now if it takes 35 minutes to fill up the bottom half, it will take 19 times 5 equals 95 minutes to fill up the top half. AMC10B Problem 20. So 4 congruent semicircles are inscribed in a square of side length 1 so that their diameters are on the sides of the square. One endpoint of each diameter is at the vertex of the square, and adjacent semicircles are tangent to each other. A small circle centered at the center of the square is tangent to each of the 4 semicircles as shown below. The diameter of a small circle can be written as square root a plus b times square root c plus d. What is a plus b plus c plus d? So first of all, let's connect these two centers. Let's first find the side length of the large circle. So now this is 2r, and this is r, if we just set the large circle as r. And so this is 1 minus r, because this is r. So now we can do Pythagorean theorem. This is 4r squared is equal to r squared plus r squared minus 2r plus 1. This gives us 2r squared plus 2r minus 1 is equal to 0. So by quadratic formula, this is r is equal to negative 2 plus minus 12 over 2. Obviously, it can't be negative because it's a side length. We have root 3 minus 1 over 2. And also, this is over 4. Sorry. So now, let's take a look at this triangle. If we set the small radius as x, this is r plus x, and this is r plus x. So from this, since it's an isosceles right triangle, we have that r plus x root 2 is equal to 2r, or root 3 minus 1 plus 2x all over 2 is equal to root 3 minus 1 over root 2. Multiply 2 on both sides, we have root 3 minus 1 plus 2x is equal to root 6 minus root 2. So this gives us 2x is equal to root 6 minus root 2 plus minus root 3 plus 1. 2x is the diameter, which is what we want to find. So the factorization of this is root 3 minus 1 times root 2 minus 1. And so 3 plus 2 minus 1 is equal to A, 3. Thank you guys for watching.